So, in this chapter, periodic classification of elements, right? We are doing. Let me take a pen. Okay. Here, what do you mean by classification? That we have to understand. What is the importance of classification? Why we should classify? Okay, of elements. So, in this chapter, we are totally going to study about classification. How they classify the elements. So actually right now only we have how many elements? We have 118 elements. Right now we know that 118 elements. Okay. So 118 elements we have. If you want to study the properties of these 118 elements, is it an easy task? If you want to study the physical property of these elements, or if you want to study chemical properties, suppose if you want to study physical properties, okay, chemical properties of these elements, is it a easy task? What you have to do? You have to start learning, you have to start studying the physical property and chemical property of each and every element continuously. So why we do classification? Suppose if you want to understand the importance and what you mean by classification, suppose I think you guys have visited a shopping mall, right? Shopping mall. You guys have visited retail stores like supermarkets, like supermarkets. So where they have arranged the things in a proper manner. Suppose they have arranged biscuits in one bracket, biscuits in one rack. So in this rack you are going to get only biscuits, you are not able to get other than this. And they have arranged home appliances in one rack, they have arranged kids accessories in one rack, they have arranged masala items in one rack. You might have seen this. So you don't find any other things in this rack. If it is masala rack, you will find only masalas. And they have arranged for one rack, they may have arranged it for snacks. Here you are going to find only snacks, you are not going to find any households. In some, let's say, they may have arranged personal care items, let's soap, shampoos and everything. So because of this arrangement, so when a customer enters into the shop, he can easily access his requirements. His work becomes very easy. Suppose, so this is the one case. You just keep in your mind that this is the case of this app. So here shopkeeper arranged all his things in a very proper manner, so that whenever a shop customer enters into his shop, he can access his requirement, he can find his requirement, he can purchase the things very easily. His work becomes very easy, and shopkeeper's work also become very easy in order to maintain the inventory, in order to track the products. So everything, the work becomes very easy for him. Why? Because of this arrangement. Because of this arrangement, the work of the shopkeeper and the work of the customer is becoming very easy. Suppose here we have one more shopkeeper. Let's Here we have one more shopkeeper. Let's take this, called Raju. But this guy was very lazy. What he did, he didn't arrange the things in a proper manner. He brought all those things and he kept somewhere, wherever. He messed everything here. He messed up everything. He mixed everything and he just stored all of them over here. Now, if any customer enters here, suppose if any customer, let's say if you guys enter into his shop, if you want to purchase toothpaste, what you have to do? You have to search here, right? You have to search here. But if that is in the same case, if you enter into this shop, if you want to purchase toothpaste, you are not going to search all these area, right? Here we have to search entire area to get the toothpaste. So it is according to our luck. If our luck is good, we may get toothpaste here only. If our luck is not good and shopkeeper's luck is not good, we may get toothpaste after 1 hour. We may get wherever in this. Here we may get, here these may get arranged. We don't know where it is because he has mixed. But in this shop, but if you visit to this shop, if you want to purchase a toothpaste, where you supposed to go? You have to go to the this rack only, because this rack contains personal care items. In personal care items, you are going to get toothpaste. Understood? So in personal care items only. See, the work has become very simple here. So that is the importance of classification. So here what we have did, we have classified all these products. I have got so many products, right? So what this shopkeeper did here, this shopkeeper, he just classified all of those products based on their usages, based on their usages, based on some aspect only. What he did, he classified them, he didn't mix them. But this Raju guy, what he did, he didn't classify them, he didn't segregated them, he kept everything in the same place only. But because of that, we were not able to accessing the product accessing the product here becomes very difficult task. Product accessing becomes very difficult here, but accessing a product in this shop becomes very easy. Understood? I hope you understood. Let me remove all these things. Understood this? Okay. I'll just take this, I'll just name this shop as a Ravi shop. Okay, I will tell you the differences between Raju and Ravi. Here, Ravi, what he did actually, and Raju. Here, difference you can see. Ravi, what he did, whatever the products he has brought, he bought, he products. So he arranged these products, he segregated these products into different categories. Let some personal care, kids care, masala items, etc. Let's say household, like this. But whatever the products Raju has brought, he didn't segregated them, he just mixed all of them and he placed those things in a single place. He didn't segregated them. Everything is messed up here. Everything is messed up. Here, if Ravi wants to maintain, if Ravi wants to access data here, access any product, so access becomes very easy here. If he wants to take any masala item, MTR masala, he can directly come to this rack and he can take it. But if Raju wants to take that same masala item from his shop, he has to search each and every part of this shop, because he has mixed everything. He don't know. He was not aware about whether the masala item is here. Sometime if his luck is very well, he will get, because it is his shop. He may be aware about it, but if somebody enters into his shop, they will get struggle here. They will not be able to find it, and the product access becomes very difficult here. Why? What is the main difference here? Why the access becoming difficult here? Because Ravi has classified his products into the groups. He classified his products into different groups. Okay, but Raju didn't classify them into the groups, because we can easily identify, right? This is personal care group. So the property of the personal care items, I can easily say, if you can take anything from here, any product from here, I can easily say this product is personal care product. Okay, personal care means what? We may have toothpaste, powders, etc. Everything we use it for our personal body care. Okay, if I take anything from here, so if I take any product from here, where is my cursor? I am not finding. Yes, here. If I take anything from here, masala, so I can easily say this is a masala item. We can use it for in cooking. We use it in cooking. Why I am saying? So it may be any kind of masala. It may be a chicken masala, mutton masala, or it may be a chaat masala. Everything is used for cooking only, right? Because their property is same. Their property is same. Because that's why only we have arranged them in a one group. Okay, because of the similar properties, we have arranged them in a one group. And if you take household material, whatever you take it from here, that is used for maintaining house. Whatever you may take, you may take Phenyl, Dettol, whatever you take here. End of the day, that is used for cleaning house. That is used for cleaning house. Why? Because their usage is same. Why use? Because based on their usage, we have grouped those under this usage household group. Okay, in the same manner, but the Raju didn't did this. Raju didn't do this. That's why he started facing accessing, difficulty in access. He started facing to difficulty in maintaining inventory, because he will not be aware about how many pieces of masalas are present, how many pieces of household items are present. So that's why he will start facing a problem of empty stock, because he will not be aware about whether the masala items are present or not. He may start facing the stockage also, because he will not be aware about masala packets, how much are present. So if he place an order for some more masala item, what happens? He will start selling the new ones. He will neglect the old ones. So many problems he is going to face. So this classification or a grouping of the things made Ravi's work very easy. Ravi's work very easy. It is because of classification. The process of arranging the products into the groups based on their basic properties is called as classification. Simple. The importance of classification, you already came to know it. What is the importance of classification? If you don't do classification, what happens? Your task becomes very difficult. So if you switch the same thing to the chemistry, here you can also see, so many books here we have given, law books. Here if I ask you to get me the law book, you can usually directly you will go to this rack and you will find it over here only, because I have arranged all law books over here. So if I ask you to get me history books, directly you will go here and you will find it and you will give me. If I ask you to give me poetry, directly you will go to this section and you will give me. If I ask you to give me major prophet books, you will go here and you will give me. If I ask you to give me minor prophet groups, you will go here and you will give me. Like that here, I have arranged books in a different category. If you know this, whatever the books which are present in this law category, all will talk about law. Everything, their property is same. They talks about only law, Indian Penal Code section, or it may be foreign law. Okay, anything it talks about law only. But whatever the books here we have, all of these books talks about history. It may be a prehistory, it may be a written history, or it may be Indian history, world history. End of the day, all of these books talks about history only. Why? Because it's their properties, based on their content we have arranged. If you go here you will get, you may take this book, you may take this book, this book. All of these books will contain poems, because these are called as poetry. So why we based on their properties, we have arranged, we have grouped them. Why? Because all of these have similar properties. Here also all of these have similar property. Let me change my pen. Color, and sorry, let me change my pen. Felt tip pen I will take. Okay, here So all of these have their similar properties. Okay, all of these talks about law, that's why we have grouped them in a same group like that. What about if I didn't arrange these books in this manner? If I just simply mixed these all the books in a single rack, if I place all the books in a single rack, if I ask you to give me a law book, what are you supposed to do? You need to search each and every whole throughout rack, you have to search, right? So that is searching becomes very difficult here. Here the searching becomes very easy, accessing the books becomes very easy. Why? Because here we are following the classification, but here we are not following the classification. Even if you want to study about geology, you should know classification of human beings. Okay, then I hope you understood. So I will share the document, the definition of classification and everything. Simply, if you want to say general definition of classification, you can write like this: grouping of things depends. If you are talking about classification of elements, grouping of elements you can use in place of these things. If you are talking about classification of animals, you can say grouping of animals, you can say grouping of things. Or if you are talking about classification of species, you can say grouping of species, you can say grouping of things based on similar properties. Similar, it may be their chemical properties or it may be their physical properties. I'll just say simply, I'll put it as a properties. Similar properties is called classification. Is called classification. That's it. If you want a proper definition, I'll just share that document, or you just refer. Google it out, you will get. Or else I will share the document in the group. You will come to know it. So guys, I hope you are getting everything. Let me pause. If you want to know what is classification of elements, see this. Okay, classification of elements. So here we have so many elements: hydrogen, helium, lithium, beryllium, boron, carbon. Okay, let me take some different color here, felt tip point, and let me take some thick color. I'll take K. Okay, here we have boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, like that. We have so many elements here. How do you classify these elements? If you want to study, so here we are not going to access. If you want to study about hydrogen, or if you want to study about iodine, or if you want to study about this, or if you want to study about this, or if you want to study about Rutherfordium, where we have 117, I think so. Back. So if you want to study about this, or if you want to study about this, here RF, Rutherfordium, how are you going to study? So what is the base here? So your study is very difficult here. If you want to study the properties of the element now, it is very difficult. Why? Because it is difficult, because we have totally 118 elements. If you want to study the properties of these elements, you have to study the properties of 118 elements only. Is it an easy task to remember all the chemical properties, physical properties of these elements individually? Is it an easy task? No, it's a very difficult task. So for that, what we will do, we will try to do classification. The same question has arisen when our ancestors ancestors found and discovered an elements. When our ancestors discovered an elements, they started facing this problem only. Their study becomes very difficult. Their study started becoming of elements becomes very difficult. Their study started becoming very difficult and difficult. So that's why our ancestor decided to classify these elements based on suburb. I already told you classification is nothing but what? Grouping of elements based on their properties. Suppose I will group these elements in one group. I will name it as a group 1. I will name these elements as a group 2. I will name these elements as a group 3 based on some properties. So what is the base we can take here? That is a similarity between those. If you find similar chemical properties between these elements, if you find similar based on similar chemical properties, let's based on atomic mass. So various things are there, elements related to the information of the elements. How we come to know whether these two elements? When you study. So our ancestors, what they did actually? Our ancestors, they studied each and every element. They studied each and every element's properties. So properties may be chemical properties and physical properties. Based on their studies, so many guys tried to classify the elements according to their observation and according to their plan. In that, we have some important things to discuss. Here, Dobrenier is one of our ancestor, a great scientist, a great chemistry, and he is the first person who tried to classify the known elements at that time. 30 plus elements were known during the period of Dobrenier. The name of the scientist it is here. So this guy, okay, this is the name, Dobrenier. It's the name of a guy. This guy name. Pride means group of 3. Tried means what? Tried means like this. One group of 3 elements. For group of 3 element, he called it as a triad. So like this, he made elements in a group of 3s based on their properties. Okay, he called them as a triads. Triads means group of 3. Group of 3 elements. Okay, so Dobrenian tried to classify elements in 3 groups. What he did? He tried to classify the noun elements in 3 groups, and he called those groups as a triads. But on what base? On what base? That is, see here, first point you can see. Let me take this one. See here, if you see first point, he made a group of 3 elements. He made a group of 3 elements. That means he made a group of 3 elements having similar chemical properties. That means, see here, this is very important. Similar chemical properties. We will see that also. I will tell you. I'll take a one group and we will see. Having similar chemical properties, and he called that group. He called his group. He called that group as a group of 3 elements as a triad. As a triad. Okay, so simple. Then what he did is simply, if you want to see, I'll take one example here. I'll just take one simple example. So suppose what he did, he grouped the elements 3 groups. Let's say A, B, C. Here these are the 3 elements. which have their same chemical properties. Same chemical properties. That may be their oxides, their hydrides and everything. So these are the three elements which have their same chemical properties, and he arranged them in a 3 groups, and he called it as a tride. So based on their chemical properties, he found, suppose we had elements like A, B, C, X, Y, Z, L, M, N, like this element we had OP. So he studied the properties, chemical properties of all these elements. He studied the chemical properties of all the elements. After studying, he came to know that the chemical properties of ABC resembles, that means the same, and hence he grouped those three elements in one group, and he called it as a 3. And he tried to group the elements in 3 only, and he called it as a tride 1. And after some time, he found XYZ. The chemical properties of XYZ were resembling, and he made them as a one more tride. And he gave us only 3 trides, and after that he said that all the elements will exist in this fashion only. And he did his experiment for only 3 trides, and he found that LMN were also the elements which are showing same properties. He said it is third tride. Okay, simply he grouped 3 elements in a group based on their chemical properties. So what is that chemical property here? So when it is going to happen, see in the second line he is saying, when the elements are arranged in increasing order of their atomic mass. Atomic mass means what? Weight of an element. Weight of element. What is the weight of element? It is the weight of an atom. So which is resides at the center. It is the weight of a nucleus. Weight of a nucleus is going to be your atomic mass. Okay. So when elements are arranged in increasing order of their atomic masses, suppose here we have A, B, C, D, U, V, okay, let's say. Suppose the atomic mass of A is 2, atomic mass of B is 3, and atomic mass of C is 4, 5, 6, 7. We have to arrange increasing order of their atomic masses. Once you arrange increasing, let's say I will arrange this A, B, C, D, E, F, Z, H, I. These are my elements, and their atomic masses, let's say it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So what you have to do? You just arrange these elements in increasing order of their atomic masses. Yes, I did, right? These are the atomic masses. I have arranged all of them in increasing order of their atomic masses. Next, what he is saying, let's see that. Atomic masses. Then atomic mass of a middle element. Atomic mass of a middle element is equal to the average atomic mass of a first and third element. That's it, simple. So here what I did, simple, he is Dobranian. He first thing, let me erase this so that you will come to know it. Simply, whatever the elements he has got, first he arranged all the elements in their increasing order of their atomic masses, A, B, C, D, let's say E, F, Z, H, I, J. And according to this, based on their similar properties, he grouped them in 3 groups, 3 elements. He made a group of 3 elements. Let's like this. K, L. Okay. And their atomic masses, let's say it is 1, 2, 3. Say it is 4, 6, 8. Say it is 10, 12, 15. Let's say it is 16, 18 and 20, like this. So now I have arranged all the elements in increasing order of their atomic masses, and I have arranged in the trides also. Now what next he is saying here, the average atomic mass of a middle element. So here in the tride, so let's concentrate on the tride first. So this is my one tride. Then atomic mass of a middle element, that means middle elements. The atomic masses of middle elements of a tride. The atomic mass of a middle element is equal to the average atomic mass of first and third element. If you take average atomic mass of these two, and if you take average atomic mass of these two, and if you take average atomic mass of these two, and if you take average atomic mass of these two, so you are going to get a atomic mass of middle element. You are going to get a atomic mass of middle element. So suppose what I is saying, if you want to get average atomic mass, now I don't know the atomic mass of B, and here I don't know the atomic mass of this, and here I don't know the atomic mass of this middle one, I don't know the atomic mass of this. So if you want to find out the atomic mass of a middle element, exactly, so what we have to do, we have to take average atomic mass. I have to add the masses of mass of first element and second element, and I have to divide it by 2. Average, you know, here average atomic mass D plus F by 2, here G plus I by 2, here J plus L by 2. So this will gives you the atomic mass of a middle element, that is B. This will gives you the atomic mass of a middle element, say E. This will gives you the atomic mass of a middle element, say H. This will gives you a atomic mass of a middle element, say K. This is what he said. Simple thing. So first thing, he arranged elements in 3 groups. Just remember here, elements in group of 3, that is called group of 3, that is called tride. Then those elements, every element he arranged in increasing order of their atomic masses. When you arrange all these groups in increasing order of their atomic masses, order of their atomic mass, atomic mass, keep in your mind, it is mass. So what happens here in the tride, the atomic mass of a middle element, here this is tride 1, this is tride 2, and tride 3, and it is tride 4. In every tride, the atomic mass of a middle element is exactly equal to the average atomic mass of a first and last element. Atomic mass of a middle element is exactly equal to the average atomic mass of a first and last element. Here atomic mass of a third element is exactly equal to the first and last element. Here atomic mass of a third element is exactly equal to the first and last element. Understood this? This is what the Debrerian said. For that, on this also, he gave us 3 trides. He gave us only 3 trides. He gave us only 3 trides. 3 trides. He didn't did his experiment for the remaining trides, because during his period we were now only 30 plus elements. During his period 30 plus elements were discovered. Only 30 plus elements were discovered. Sorry. Okay, I hope you guys understood. Please copy this. I will give you some. Okay, let's continue. I'll go to the next slide here. So these are the 3 important trides given by the Debrerian. He has given this 3 trides. First tride is lithium, sodium, and potassium. Okay, these are the 3 elements he grouped. See here, lithium is, okay, I will also see. And the atomic mass of lithium is 7, atomic mass of sodium is 23, and atomic mass of potassium is 39. And he has given this tride also, chlorine, bromine, and iodine. He grouped all these 3 in a single tride. And the atomic mass of chlorine is 35.5, atomic mass of bromine is 80, and atomic mass of iodine is 127. At the same time, he has given the last tride, that is calcium, strontium and barium. So atomic mass of calcium is 40, atomic mass of strontium is 88, and atomic mass of barium is 137. See what he was saying. Let me take pen here. Highlighter doesn't work here. Ballpoint pen. See here. So he has given this tride, that is Li, sodium is Na, and potassium is K. I'll simply say it is LINAC. Lithium, sodium and potassium. So this is one tride. Okay, this is first element, this is second element, and this is third element. It is a group of 3 elements. Okay, here, so this is the tride. What she said, and atomic masses, if you see, it is 7, which is also in increasing order, 23 and 39. Yes, atomic masses of these elements are also in a increasing order of their. So he said, according to the Dobrinian, we have arranged elements in increasing order of their atomic masses, and we have grouped elements having similar properties in 3 groups. Okay, now, so the atomic mass of a middle element is equal to, that means atomic mass of sodium is equal to average atomic mass of lithium plus potassium. The atomic mass of lithium, potassium divided by 2 gives you the atomic mass of sodium. So simple, he has given the atomic mass of lithium we know, that is, and atomic mass of potassium we know, that is 39. See here, 7 plus 39 upon 2. So 7 plus 39 will be your 46 upon 2, which gives you 23. So 23, that means it is 7 and it is 39 and it is 23. Yes, the atomic mass of sodium is also 23 only. In the first attempt, in the first tride, he got exact answer. He got a exact answer in the first tride. So he become happy and he tried for the next tride, that is chlorine, bromine and iodine. Okay, the atomic mass of chlorine is 35.5 and the atomic mass of iodine is 127, and we know that atomic mass of bromine is 80, but according to this guy, whether we get the atomic mass of a bromine should be equal to what? Atomic mass of this bromine should be equal to average atomic mass of chlorine, Cl, plus iodine by 2. Okay, so what is the average atomic mass of chlorine? The iodine is 127 and chlorine is 35.5. If we add these two things and if you divide it by, you will get atomic mass of bromine. How much we got here? 81.25. But the atomic mass of bromine is 80, and we are getting little bit extra thing here. It is acceptable, 1.25, and this we can neglige. If this difference rises too much, then this law cannot obey here. The difference is very light, so we can accept, we can convert that into 80, and here the second tride is also accepted, and he has also given third tride, 40, 88 and 137 atomic masses, that is calcium and strontium and barium. Then the average atomic mass of a strontium is equal to average atomic mass of calcium, first element and second element, here 40 plus 137, so you will get 88.5 here. Anyhow, the difference is very light, so it is negligible, and we have got the answer. But this Dobrinian gave these only 3 trides. He didn't try this experiment for all the remaining elements. Okay, once we tried it for the remaining elements, the difference what we were getting, right, the average atomic mass difference here in the first case, we have got exactly. In the second case we have bit 1.25 extra. Here we got 0.5 extra. As we did the same experiment for some other elements, this difference becomes very larger. This difference started increasing drastically. this difference started. So this difference, what we have, right, it has started increasing drastically. The difference is started increasing drastically. So in the first case we have got exact one, in the second case we have got some difference, here also we have got some difference. But if we do it for higher atomic mass elements, so we started getting difference, very high difference, hence the law get rejected. This law get rejected because this law applied for initial 3 trides only. This law is applied for initial 3 trides only. It applied for initial 3 trides only. So those are these 3 trides. Those are LINAC, that is lithium, sodium, potassium, and chlorine, halogen it is chlorine, bromine, and iodine, ClBr, CBI. Then we have CSB, calcium, strontium, and barium. These are the 3 trides. This law obeyed for only these 3 trides. For remaining higher atomic mass elements and lower atomic mass elements, this law was failed because the difference here, the average atomic mass difference, we started getting a too much high difference here. Here we have got 1.25 difference, here we got 0.5 difference. Okay, like that we started getting too much high difference. Here we started getting so if the atomic mass was 23, we get 27, like that. 4 difference, this much of difference we started getting. So that's why this law get rejected. If we want to see drawbacks of Dobrynyan tride, Dobrynyan was able to identify only 3 trides. He was able to identify 3 trides. He even not tried to identify it from the elements known at that time. Hence the system of classification into tride was not found to be useful for classifying many other elements which were not able to form any tride like previous 3 trides. Okay, for higher elements, remaining elements didn't followed the Dobrynyan tride. If you take some other 3 elements which were known during that time, so this law was not applicable. So hence this law get rejected. Okay, let's after this guy, but why we are studying this Dobrynyan? Because he is the person who started classifying the elements. Why? See, what is the impact of classification? Suppose here he has grouped, so let me explain here. He grouped those elements 3 trides, right? I will just tell you the importance of those 3 trides only. So here he has grouped lithium, sodium, and potassium. If you want to study the properties of this element, here no need to study the properties of all these 3 elements. You don't need to study. If you know the properties of this tride, because all these elements have similar properties, that's why we have grouped in a same tride. So that the elements belongs to same tride will have a similar properties, that we know, right? So like that, if you see lithium, sodium, potassium, all of them have only one valence electron in their outer shell. If they have only one electron, then chemical properties will also same. They provide oxides, same oxides. They give the same hydrides. Their chemical properties are also same. And if you see, lithium is a metal, sodium is also metal, potassium is also metal. Everything is metal. The properties, physical properties, chemical properties are similar. So because of that only he arranged all these things. So you no need to study the properties of all of these elements. If you know the group 1, here the tride 1, if you know this tride 1 elements are metals, so no need to study. You can study, instead of studying 3 elements properties, you can only study about the group, that is the properties of only one group, one tride properties. If you study the properties of this tride, so the whatever the elements are belongs to that tride will have that property only, so that our study becomes easy here. And he is the first person who tried to classify the known elements. That's why we have to study his idea. So his idea was applied for initial three traits. It was not applicable for remaining elements. That's why his idea has been cancelled out. Then after some time, one more candidate came into the picture, and he also tried to classify the elements. During his period, we were now about 50 elements or something around 50 elements, I think so. Okay, this much of elements we were known. And this guy here, what we have, he is called as Newland, the name of a person. So in your NCERT book, you can find his complete name, and you can find about him also. And this guy was is very fond of music, was very fond of music. So you can say he is a music lover, he is a very fond of music. So this guy, what he did, he tried to classify the noun elements, whatever the noun elements we had at that time. He tried to classify those noun elements based on the musical notes. See here, sa, re, ga, ma, pa, da, ni. After ni, we will get sa only. Sa, re, ga, ma, pa, da, ni, sa. Every eighth tone is repeating here. So in English, what we say, do, re, mi, fa, so, la, ti. This is English musical notes, and this is our normal Hindi, Kannada, other language musical notes. Okay, according to them, because he was very fond of musical music, he tried to classify the elements based on the musical notes only. Because in the musical notes, if you see, every eighth element, every eighth note, so this is first note, second note, third note, fourth note, fifth note, sixth note, seventh note. For every eighth note is resembles the first note only. Okay, eighth note is what here? If you say eighth note, again you say first note only, right? What is the eighth note here? Sa, re, ga, ma, pa, da, ni, sa. Every eighth element will here. So in this manner, he tried to classify the elements. Okay, he did that also. See here, he classified hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. Eighth element should possess the properties of first element. See here, fluorine. Hydrogen and fluorine should possess same properties. Next here, sodium, magnesium, aluminium, silicon, phosphorus, like this. And after this, eighth element should possess chlorine. See here, this fluorine and chlorine both are halogens, and they are possessing same properties. In the same manner, he arranged it like this. If you start counting from here, if you start counting from lithium, this is first, second, third, fourth, fifth, sixth, seventh. Every eighth element should possess the properties of first element. See here, lithium was metal and sodium is also metal. Like this, it was applicable. Suppose if you start counting from here, 1, 2, 3, 4, 5, 6, 7. Every eighth element should possess the properties of first element. This was the first element, right? Eighth element should possess the properties of first element. Here it was the eighth element. And here magnesium and calcium, both are metals. Both have +2 valence electron, and their chemical properties and everything is same. If your counting starts from aluminum here, from here if it is 1, 2, 3, 4, so 5, 6, 7, thus 8th element chromium we have, right? That is belongs to boron family only. Aluminum and chlorine will have same properties. It is also having +3 valence electron. It is also have a +3 valence. And here if you see, all the elements which have a similar properties, they are grouped in a single group. See here, grouped in a single group. But even we have some problems here. So here cobalt and nickel, they don't have similar properties, but they are grouped in single, same slot. Okay, this is how he arranged Newlands. Okay, what is the law he said after doing his experiment and arranging elements like this? He said that when you arrange elements in increasing order of their atomic masses, yes, the main concept again, what was there in the Dobrenier, the same thing he is also using. Dobrenier also what he did, he arranged the elements in increasing order of their atomic masses. And this guy is also what he is doing, he is also arranging elements in increasing order of their atomic masses. Let me take one slide here. Oh, okay, sorry, we don't have a space. Yes, let me remove this. Oh, sorry. Let me erase all this. Okay, this guy, suppose if you have elements, let's say a, if you have elements, some elements, what we have to do first, we have to arrange all of the elements in increasing order of their atomic mass. This is the one thing, increasing order of their atomic masses, increasing order of their atomic mass. Okay, let's, I will arrange, I know these elements A, B, C, D, E, F, Z. But second point, he said that every eighth element, okay, if you arrange 7 elements, right, every eighth element should possess the, every eighth element will have a similar properties to its first element. Every eighth element will possess means have, possess the properties of the first element. Okay, properties of first element. Okay, see here, this is first element, 1, 2, 3, 4, 5, 6, 7. So eighth element should possess the same property, right? Eighth element should be similar to this, hence I will write here. A and H have similar properties. So from here, H, I, J, K, L, M, N. After this, eighth element should possess this properties, M here. If your counting starts from here, this will be your eighth element. Hence, these two will become similar. Elements become so. So he is the person who grouped the elements in a vertical manner. See, one group which has the same properties. Here, this is second group which has the same properties. This is third group which has the elements belongs to third group. If you know this property of this first group, you no need to study about the properties of individual elements. You can easily say the properties of all these elements here. Like this, he made 7 groups. He made 7 groups. He arranged elements in 7 groups. This is what his law. Okay. So when you arrange elements in increasing order of their atomic masses, see here, when elements are arranged in increasing order of their atomic masses, then every eighth element possess similar properties of, here I forgot this, of first element. You have to write this first element. I forgot to write this. Let me erase and write it. Okay, first element. Okay, here it will possess the properties of a first element. As for the musical tones here, in musical tone also it was same only. Every eighth tone, after seventh tone, you are going to say eighth tone, first tone only, right? Like that one. Copy this fast. I'll just give you some time. You copy this slide. Let me take pen here. Well, tip point. Then we'll go to the next slide. Limitations of laws of octaves. Okay, why it has got octaves? Because the elements are arranged in every eighth element possesses the properties of first element. First limitation here, Let me take a highlighter here. See here, the several elements were fit into the same slots. Okay, so in single slot several elements were placed. Example, cobalt and nickel. See in this, if I go back, see here, you can see here cobalt and nickel are placed in same slot. Even they have a difference in atomic masses, we have placed them in a same slot. Why? Because both has the same properties compared to chlorine. And here see, this one and this one, like this several elements were grouped in same slot. That was the main drawback of this. See, several elements were fit into the same slot. First drawback. So example, cobalt and nickel were placed in the same slot. Okay, because, and the second one, dissimilar elements were grouped together. Like halogens were grouped with some metals. See here, example, what is there? Dissimilar elements means having different characters, chemical properties or physical properties. They were grouped in a same group. I'll just show you that here. So here fluorine and chlorine both are halogens. Okay, both are halogens, and these two are not metals actually. These are non-metals, but they are grouped with the metals here. Cobalt and nickel, both are metals, and here bromide. So fluorine, chlorine are halogens, and they are completely different in their properties, and cobalt and nickel are metals, and they are also completely different. So dissimilar elements are grouped in a single group here, if you can see. But here if you see, all are similar elements in this group. In the second group, here nickel is metal, sodium is metal, potassium metal, cadmium, copper is metal, rubidium is also metal. So whereas here beryllium, magnesium, calcium, zinc and strontium, all are metals. But in this case only, what happened here, halogens are not metals, they were non-metals, and their property is completely different. Along with the halogens, we have grouped some dissimilar elements like cobalt and nickel, which are metals. Okay, that is what happened. The second disadvantage of the Newland's law. If you follow this Newland's law of octaves, so you are going to group dissimilar elements in a same group. That is what the second disadvantage. Dissimilar elements were grouped together. Example, we grouped halogens and some metals like cobalt, nickel and platinum. We grouped all the halogens like chlorine, okay, then fluorine and cobalt and nickel and platinum. And the third one, it applied for initial 20 elements, that is initial 20 elements till calcium, which has lower atomic masses elements. This law of Newland's applied for only for initial 20 elements. You can say it applied for only till calcium only. Till calcium, because calcium is a 20th element, it applied till calcium. It didn't apply for the higher atomic mass elements. After that, it didn't apply. This law didn't, from after the 20th, the every 8th element started possessing different properties of the first element. This law was not applicable for a higher atomic mass elements. You can simply say it, this law was applicable for lower atomic mass elements. This law was not applicable for higher atomic mass elements. Okay, if you lower atomic mass means you can say it is applied till calcium. This law was applicable till calcium. So next one, last one, elements identified later, okay, in the future, after the law was been processed and accepted. So after accepting the whatever the elements were discovered in the future, they were not going to fit into this table. The table was altering. That is the one more limitation. I hope you copy this.